Very good morning to you. Objective Geology, multiple choice questions with answers. This is the solved question paper of CSIR NET Earth and Atmospheric Oceanographic Sciences 2025 question paper. And I hope this solved question paper is useful for various competitive exams like CSIR, NET, GATE, GSI and other competitive exams. Welcome to set 1. First question, the Younger Dryas is best described as which period? A. Stadial, B. Interstadial, C. Neoglacial and D. Interlude. The correct option goes as A. Stadial. The Younger Dryas was a period in the Earth's geological history that occurred 12,900 to 11,700 years before present. It is primarily known for the sudden or abrupt cooling in the northern hemisphere when the North Atlantic Ocean cooled and annual air temperature decreased by -3 degrees centigrade over North America, 2 to 6 degrees centigrade in Europe, and up to 10 degrees centigrade in Greenland in a few decades. So the Younger Dryas is best described as a stadial period. Next question. Possibility of growth of a tropical disturbance via barotropic instability can be tested by examining the A. Latitudinal variation of zonal wind, B. Longitudinal variation of meridional wind, and C. Vertical variation of zonal wind, and D. Longitudinal variation of zonal wind. The correct option goes as B. Longitudinal variation of meridional wind. The possibility of growth of a tropical disturbance via barotropic instability, it can be tested by examining the longitudinal variation of a meridional wind, though this is typically done within the broader context of analyzing the meridional shear of the zonal flow and resulting the absolute vorticity gradient. So the possibility of the growth of tropical disturbance via barotropic instability can be tested by examining the longitudinal variation of meridional wind. Next question. The 410 kilometers discontinuity primarily represents A. A change in bulk chemical composition, B. The change of olivine to wärtsilite, and C. The change of olivine to ringwoodite, and D. The appearance of bridgmanite. The correct option goes as B. The change of olivine to wärtsilite. The 410 kilometer discontinuity primarily represents the mineralogical phase change of olivine to wärtsilite. At this depth, pressure causes the olivine structure to rearrange into a denser, modified spinel structure called as a wärtsilite, that is magnesium silica Mg2SiO4. Next question. Complete melting of Arctic sea ice within a year will immediately A. Increase global sea level, B. Increase Arctic sea level only, C. Not change in the global sea level, and D. Increase surface salinity of the Arctic Ocean. The correct option goes as C. Not change in the global sea level. Complete melting of Arctic sea ice, which is already floating, it would cause no significant change in the global sea levels because the ice is already displacing its own volume in the ocean. However, it would increase or it would cause major indirect effects such as accelerating global warming via decreased low albedo sea surface, leading to rapid melting of land-based ice, that is example as Greenland, which does rises sea levels. So complete melting of Arctic sea ice within a year will immediately not change in the global sea level. Next question. Deep focus earthquakes occur at which depth? The options given are A. Crustal, B. Lithosphere, C. Upper mantle, and D. Lower mantle. Deep focus earthquakes occur at upper mantle. Deep focus earthquakes typically occur at depths of 300 to 700 kilometers below the Earth's surface, predominantly within the lower portion of the upper mantle, and sometimes it extends near or into the top of the lower mantle. So these also called as plutonic earthquakes, they occur along the convergent boundaries or subduction zones. So the correct option goes as the deep focus earthquakes at upper mantle. Next question. In a Morse circle, the radius represents A. Mean stress, B. Differential stress, C. Shear stress, and D. Lithostatic stress. The correct option goes as C. Shear stress. The radius of Morse circle, it represents the maximum in-plane shear stresses, and it is calculated using the normal stresses and shear stress on a plane. So in a Mohr circle, the radius represents shear stress. Next question, what is the major source of heat in the Earth's continental crust? The options given are A. Primordial heat, B. Plate tectonics, C. Radioactive decay, and D. Convection currents. The correct option goes as C. Radioactive decay. The major source of heat in the Earth's continental crust is the radioactive decay of isotopes, primarily uranium-238, uranium-235, thorium-232, and potassium-40. These radioactive elements are concentrated in the continental crust and produce heat through radiogenic heat production. So the correct option goes as C. Radioactive decay. Next question. Which one of the following relates to the management of soil erosion? A. Stone line, B. Log line, C. Tree line, and D. Shrub line. Correct option goes as D. Shrub line. Shrub lines and shrub vegetation are directly related to the management of soil erosion, primarily acting as a biological control method to stabilize soil on the slopes and in arid or semi-arid regions. And these are considered highly efficient in reducing surface runoff, which is a major driver of erosion. Next question. Inselbergs are most common on A. Sandstones and limestones, B. Mudstones and syenites, C. Limestones and granites, and D. Granites and gneisses. The correct option goes as D. Granites and gneisses. Inselbergs are most common on granites and gneisses. These rocks are highly resistant to weathering and erosion, allowing them to remain as isolated, steep-sided, and often dome-shaped residual hills that rise abruptly from surrounding plains. And these are the classic features of arid and semi-arid landscapes. So Inselbergs are most common on granites and gneisses. Next question. The Curie point is defined as the temperature above which a material becomes A. Ferromagnetic and paramagnetic, B. Paramagnetic and ferromagnetic, C. Ferromagnetic and ferrimagnetic, and D. Ferromagnetic and diamagnetic. The correct option goes as A. Ferromagnetic and paramagnetic. The Curie point or Curie temperature is defined as the temperature above which a ferromagnetic material becomes paramagnetic. At this critical temperature, the material loses its spontaneous permanent magnetic properties, or it is also known as ferromagnetism, due to the thermal agitation overcoming the exchange interaction, causing the magnetic moments to become disordered. So the Curie point is defined as the temperature above which a material becomes ferromagnetic and then paramagnetic. A is the correct option. Next question. The Earth's magnetic field can be approximately modeled by which source field? A. Quadrupole, B. Tripole, C. Dipole, and D. Monopole. The correct option goes as C. Dipole. The Earth's magnetic field is approximately modeled by a magnetic dipole field or a magnetic dipole source. So the dipole model is, this is an approximation which holds for 80 to 90% of the Earth's field, and it imagines a giant invisible bar magnet or magnetic dipole which is placed at the center of the Earth. Next question. Which one of the following features record the location of past ice-walled or subglacial streams or channels? The options are A. Moulins, B. Cames, C. Eskers, and D. Kettle holes. The correct option goes as C. Eskers. Eskers are long, winding ridges composed of stratified sand and gravel that record the location of past subglacial or ice-walled streams or channels. And these are essentially inverted river channels that formed when meltwater streams flowing within or beneath the glaciers deposited sediment that remained as a ridge after the ice which has melted. So eskers are the features which record the location of past ice-walled or subglacial streams or channels. Next question. The sediments deposited in the delta region of the Ganga-Brahmaputra rivers at a depth of 50 meters during the last glacial maximum will contain A. Both marine and terrestrial fractions, B. Only marine clastic fraction, and C. Only terrestrial fraction, and D. Only marine orthogenic fraction. The correct option goes as A, both marine and terrestrial fractions. Sediments deposited in the Ganges-Brahmaputra Delta region at a depth of 50 meters during the last glacial maximum (LGM) typically contain both marine and terrestrial fractions. And the lower sea levels, approximately 100 to 120 meters below the present, are forced the coastline far out, causing the Ganga Brahmaputra to deposit terrestrial, fluvial, and floodplain sediments in the area that became a mix of continental shelf and coastal to shallow marine environment during the marine transgression. The sediments deposited in the delta region of the Ganga Brahmaputra rivers at a depth of 50 meters during the last glacial maximum will contain both marine and terrestrial fractions. A is the correct option. Next question. A 1 in 25-year flood has a how much percentage probability of occurring in any 1 year? The options are A 2.5, B 25, C 4 and D 40. A 1 in 25-year flood, it has a 4% probability of occurring in any 1 year. The probability of a flood event occurring in any given year, it is often referred to as the annual exceedance probability or AEP, which is the inverse of its return period or the average interval between the events. So a 1 in 25-year flood has a 4% probability of occurring in any 1 year. C is the correct option. Next question. Which one of the following elements remain largely conserved in the ocean? Options are A. Lead, B. Thorium, C. Silicon, and D. Molybdenum. The correct option goes as molybdenum. Molybdenum is considered one of the elements that remain largely conservative or conserved in the open ocean, meaning its concentration relatively constant. It is throughout the water column and it correlates directly with the salinity. And molybdenum has a very long residence time in the ocean, that is approximately 7,40,000 to 8 lakh years, which is much longer than the ocean's mixing time. So molybdenum element, it remains largely conserved in the ocean. D is the correct option. Next question. In the northern hemisphere, the major ocean currents lend the curve to the right due to A. Cyclonic eddies, B. Wind shear, C. Density gradient, and D. Coriolis force. The option goes as the correct option is D. Coriolis force. In the northern hemisphere, major ocean currents curve to the right due to the Coriolis effect, and this is caused by the rotation of the earth, and this apparent force, it deflects moving water and air to the right of its path in the northern hemisphere, resulting in clockwise rotating ocean gyres. So, in the northern hemisphere, the major ocean currents lend the curve to the right due to Coriolis force. D is the correct option. Next question. Banded iron formations formed during the Precambrian because of A. Conversion of Fe2 plus through Fe3 plus during chemical weathering, B. Formation of stable cratons, and C. Conversion of Fe3 plus to Fe2 plus in the water column, and D. Conversion of Fe2 plus to Fe3 plus in the water column. The correct option goes as D. Conversion of Fe2 plus to Fe3 plus in the water column. Banded iron formations or BIFs formed during the Precambrian, roughly around 3.8 to 1.8 billion years. Primarily, it is because of the conversion of soluble ferrous iron, that is Fe2 plus, to insoluble ferric iron, Fe3 plus in the ocean water column. Precambrian oceans were anoxic, that means they lacked oxygen, and they allowing vast amounts of irons released from the hydrothermal events and continental weathering to accumulate in the water as soluble ferrous, that is Fe plus 2 to Fe plus 3. So the conversion of Fe2 to Fe3 plus, it is a photosynthetic cyanobacteria evolved, and they have begun producing the free oxygen as a byproduct. So this oxygen reacted with the dissolved in the water column, which is causing oxidizing to ferric iron. So precipitation, while Fe2 plus is soluble, Fe3 plus is highly insoluble, and it reacted with the water to form iron hydroxide or iron oxides, which then precipitated to the seafloor, forming the oxidized iron such as hematite and magnetite. Next question. Standing stock is a term used to represent the productivity of the ocean. Which of the following represents standing stock? A. Total weight of all organisms in a given area or volume of water. B. Number of organisms per unit area or per unit volume of water. And C. Total number of phytoplankton in unit area or unit volume of water. And D. Total number of zooplankton in unit area or unit volume of water. The correct option goes as A. Total weight of all organisms in a given area or volume of water. In ocean productivity, the term standing stock, it is also known as the standing crop. It refers to the total biomass of living organisms present in a specific volume of water at any given moment. Next question. Which one of the following properties is essential for the existence of large-scale atmospheric waves? A. Compressibility. B. Buoyancy. C. Viscosity. And D. Planetary vorticity. The correct option goes as D. Planetary vorticity. Planetary vorticity, specifically the gradient with respect to latitude, it is also known as the beta effect, and it is considered as one of the most essential properties for the existence and propagation of the large-scale atmospheric waves, often referred as the Rossby waves or planetary waves. So, planetary vorticity property is essential for the existence of large-scale atmospheric waves. Next question. Which one of the following rock types would be of interest for a lithium exploration program? The choices are A. Comatites, B. Metabasalt in greenstone belt, C. Granitic pegmatite, and D. Banded iron formations. The correct option goes as C. Granitic pegmatite. In a lithium exploration program focused on granitic pegmatites, and this is primarily the target, it is LCT, that is lithium cesium tantalum family of pegmatites, so which are typically derived from highly fractionated per-aluminous S-type granites. So granitic pegmatite rock types, this is of interest for lithium exploration program. Hope you have followed the content and the questions, and see you in the next video. Thank you for your time. Hope you can explore geosciences and subscribe. And if it is helpful, you can share the information to your friends. Thank you so much.